Z scores, day one. Now, what a Z-score is going to tell us is the number of standard deviations away from the mean or the average. Why do we have a Z-score? Well, we just got done talking about this yesterday or in the last video about the standard normal curve. That covers numbers of standard deviations away that are whole numbers, like 1 standard deviation away from the mean, 2 standard deviations away from the mean, 3 standard deviations away from the mean, and stuff like that. Well, with the Z-score is a decimal version, and it can be a whole number, but it's a number between 0 and probably around 3.5, 4 that tells you how many standard deviations you are away from that average. Okay, and it kind of gives us an area to go along with that. So here we've got a Z-score is X. That's your observed value. Okay, so that's your observed value. You have a mean, a population mean that you're given. You've got a standard deviation that you're given. The standard score or Z-score, meaning the same thing, is just subtracting those two top numbers and dividing by the standard deviation. Okay, so here we go. How many Z-scores, how many standard Z-scores are away from the mean? This is what I was talking about. This is the whole idea of 68% between 1 standard deviation, 95% is 2 standard deviations, and 99.7 is 3 standard deviations. Now, this only works, again, if you know you are exactly 1, 2, or 3 standard deviations away from the mean. And that's not always the case. For example, what we've got is some data here. On the x-axis, we've got these values, and I used to know what they were. Dairy production, there we go, of average of 2180. So there's the middle. What is happening here is we've got a standard deviation of 50 units, and we want to find that the average is greater than a certain number of 2100. Now, the only problem is 2100 doesn't fall exactly 1 standard deviation away. It's in between 1 below and -2 below. So I'm thinking this Z is some negative value, okay, some negative number that's in between -1 and -2. Okay, and we could actually calculate it out, but that's kind of not the point idea of this right now. Right now, it's just saying, hey, not all values are perfectly 2 standard deviations away or 1 standard deviation away. Okay, the mean and standard deviation of this data set. So we're going to practice a little bit about converting these into actual Z-scores. It helps to draw the normal curve just to get an idea where they go. But we have a distribution with a mean of 30 and a standard deviation of 5. So here we go. I'm going to go off to the side. Mean of 30, and I'm going to go with 35, 40, 45, 25, 20, 15. Okay, so there's 1 and 2 and 3 and 4 standard deviations away. Looks like 40 is one of those numbers, so 40 is going to be 2 standard deviations away. So the Z-score for 40 is 2. Or what I could do is I could take my 40, subtract 30, which is 10, divided by 5, and get 2 that way. Okay, 25. Looks like I went 1 down, so my Z-score is going to be -1. Here's how that actually calculates out. 25 minus 30 over 5, so -5 over 5, so that's Z-score of -1. Okay, see how this 40 is the number that changes, 25 changes, but the 30 and 5 stay the same because 30 is my mean and 5 is my standard deviation. So my Z-score of 31 would be 31 minus my 30, so 1 over 5.2. Z-score of 18. Now 18 is below my average, so I'm thinking I'm going to get a negative number. Divide that by 5, and I get -2.4. Now the only thing with the negative is it just tells me the direction away it is, the direction that it is above or below the mean. So since that's a negative Z-score, and how the other one's a negative Z-score, just tells me that they're below. If they're positive Z-scores, that's going to tell me that it's above. Okay, so let's start off with some applications here. So it says that the grades of a high school midterm are normally distributed with a mean of 81 and a standard deviation of 6.3. Okay, so we'll go with a normal curve here Okay, mean of 81 and a standard deviation of 6.3. So we could add 6.3 to that to get 87.3. We can subtract 87 or 6.3. We can add it and keep on going. But this will give us an idea of what it looks like. And again, we're just finding out the Z-scores anyways. So here, as I'm doing this, 65, that's below the average of 81. So I should get a negative Z-score, and I got negative 2.54. 83 is above the mean. So 83 take away 81 divided by 6.3. That should be a positive Z-score, 0.37. Okay, 93, it's above the mean, so that should be a positive Z-score as well. And I'm pumping these out pretty fast, but the idea is just take the original score, 100, take away the average, divide by the standard deviation, and that will get you your corresponding Z-scores. Okay, so a class average has a score of 75 on a Unit 10 test with an average or a standard deviation of 6. The Z-score is 1.25. So what I'll do is I'm actually given the Z-score, but not actually the raw score. And I'm going to write down what the formula has been that I've been finding these answers. And I'm just kind of putting in the knowns. So Z was 1.25. Okay. X is what we don't know. Mu is 75 and the standard deviation of 10. So I'm just going to multiply by 10 to get rid of that. That gives me 12.5. And I'm going to I'm going to add 75 to get a original score of 77.5. So that means that this person, if they got a Z-score of 1.25, had an original score of 77.5. Which makes sense because we've got a positive Z-score. He should have done better than the average. So what does that mean about Emily here with a negative Z-score? Well, that means that she's going to have an average or a score that was below the average because of that negative Z-score. So same concept, just with a different Z-score. We're going to, 75 right there, multiply by 10, add the 75, and get a original score that she got was 67.3. Okay, so that's her original score, which makes sense. Again, it should be below the average because she got a negative Z-score. Okay, tomorrow what we'll do, or the next video here, we'll talk about actually taking those Z-scores and calculating them out with a table. But for now, just knowing that a Z-score is the number of standard deviations away from the mean. If it's positive, it's greater than the average. If it's negative, it's below the average.